Hi, everyone, and welcome to the Future Construct podcast. I am your host, Amy Peck, and today we have a fantastic guest. We have Mani Golparvar, who is the CTO and co-founder of Reconstruct, and also an associate professor at University of Illinois at Urbana. Welcome, Mani. How are you?
Thanks for having me.
So let's start with, I want to hear all about Reconstruct and that evolution and how and why you started the company. But I'd love to just hear your journey. Like, how did you get into this business? What drew you into this side of the world?
Absolutely. So let me start off by giving you an overview of Reconstruct. Reconstruct, as a company, we're a software as a service company. What we really offer is an AI-powered digital twin platform. By that, I specifically mean ability of taking in images and videos that all of us are capturing on construction sites on a daily basis. Imagine you're walking around using your cell phone device, you're taking pictures. Imagine you're using a 360 video mounted on your hard hat, walking around videotaping the site. Imagine you're flying a drone on the site. At Reconstruct, we have an engine, a computer vision engine, that automatically transforms images and videos into measurable street view experiences. Think about the street view experience that you have with maps, and imagine that being measurable. We can generate that indoors and outdoors for every construction site. We call the platform digital twin because it also brings in design. Design means three-dimensional building information models, which means semantic rich CAD models, can be as simple as a 2D drawing or can be hybrid of the two. So at any point in time, that design is being twinned against its version of the reality. So you can always see what is there versus what should be there. It's AI powered because it can automatically compare the two and track progress, track quality of work in place, and forecast risk for delays. So that's what Reconstruct offers to the market today.
And which is everything moving forward, because I think that it's going to become a standard that all companies are going to want to have a digital twin, either of their existing buildings, and then it'll become standard practice to kind of build your digital twin during construction as well. But kind of going back to your personal history, you had another company prior to Reconstruct, and which was in a completely different business. So can you share just a little bit about, your journey into this vertical?
Sure, absolutely. So by by education and training, I'm broadly a civil engineer. Let me just put it this way. What that means is, I've gone through school. I learned civil engineering, design, and construction. And throughout, all those years of education, I've always gone back and forth in terms of ability to create software for civil engineering versus practicing civil engineering. So today, after these many years, I'm a hybrid of the two. What that means is what I work on is primarily creating prototypes out of various algorithms in a broad world of AI, artificial intelligence, and I try to generate value from them in construction. When I wear my civil engineering hat, I'm always concerned about the pain points. I have worked in the industry. Many years ago, I started in oil and gas, eventually moved into infrastructure projects, and I jokingly say I graduated in the commercial building sector. But that means I worked on commercial buildings when I was practicing day to day. And I was working with a company that every year we had about 1,500 projects under execution. So many projects. And throughout that experience, I was actually able to feel a pain point that over time I realized that this is broad at the industry level. And that pain point is really understanding how much work gets done on every one of our job sites on a daily basis. So, fast forward, even today's world, 2022, you walk on certain job sites and you see there are a number of field engineers that are sitting inside of the trailer, and every day they're receiving reports from the subcontractors that they have on the job site in terms of how much work has been done. Usually these reports are even paper-based, even in 2022, or there could be a digital version of a drawing in a PDF that's been color-coded in terms of work put in place. So these engineers who are sitting in the trailer, they typically compile all that data with the goal of generating a report that can be shared with the owner, can be shared with the other contractors, can be shared with every stakeholder in the project. So everybody's in the same page in terms of how much work has been done. Unfortunately, a lot of this reporting is incomplete. It takes a lot of time to create the reports, and oftentimes there's significant time delay in offering that report. So what's ended up happening is every project you ever walk into, the trailer, we usually do weekly coordination meetings. In these meetings, you ask all those companies that have actually reported to you over the week to stand up one more time and report how much work they've done since the last coordination meeting. And imagine these reports are being delayed. And imagine you're that project manager that you've always relied on a field engineer to tell you how much work has been done. You did not get a chance to walk on the site. So from the time that the problem happens to the time that everyone gets visibility to those issues, you've effectively lost 1 week of work. Now, this can be generalized to every type of project, but then for those projects that coordination of the work matters more, larger commercial projects, this problem manifests itself more. That means issues are being stacked up, and all we are trying to do from a project management perspective is reacting to them. It doesn't have to be that way. If we can bring that layer of transparency to project team members, they can immediately see the issues and they can proactively tap off delays from happening. So I was really fascinated about finding a way to solve that problem. The problem of coordinating how much work is being done, coordinating what work needs to be done, and being able to offer that version of what is happening on site versus what was planned to be executed. And I did a lot of research in terms of what is the best medium to use that can solve this problem. By medium, I'm referring to the type of data that we sense from a job site. So you can say, well, you have images and videos. What else do you have? You can use barcodes, you can use RFID tags, you can use GPS trackers. There are all kinds of sensing devices. But if there's one medium that everybody on the job site understands and they're already using for communication, that medium would be that visual interface, images and videos. You show that to a foreman, you show that to a superintendent, project manager, all the way up to the owner. Everyone would be on the same page. So I tried to really investigate how I can tap into images as a source of truth, transform them into measurable data, and contrast them against the design. So at any point in time, you can see what is there versus what should be there. That journey started in academia, transforming into prototypes that I created. And when I came back to University of Illinois back in 2012, I started partnering with the other co-founder of the company, who happens to be a computer vision scientist. I have computer vision background, but I'm mostly on the application of computer vision. So we decided to team up and we piloted the solution. It got traction, and here we are. Fast forward, we are deployed on thousands of projects in all continents.
So at University of Illinois, you're an entrepreneurial fellow. What does that really mean? So are you really kind of working with the next generation of entrepreneurs? Because this is relatively new that you had courses on entrepreneurship. It used to be sort of rolled into the MBA programs, but they sort of spun them out now. So, what's been that evolution, and what kind of students are you working with?
Yeah, that's a really interesting question you're asking. When I got into University of Illinois, I graduated from University of Illinois too. I have 2 degrees, one in Department of Civil and Environmental Engineering and one in Department of Computer Science. When I got into the university, I was really passionate about solving a practical problem. But then going through school, specifically higher education, I realized when it comes to research, we tend to focus on fundamental problems that are more important to the scientific community, things that are more gaps in knowledge that haven't been explored and haven't been addressed and have potential for commercialization. But then again, coming from an engineering background, being passionate about solving real problems, I really wanted to see what is the path forward for me as a researcher to bridge the gap between what happens out in the field versus what we do in research. So over the years, I've strived to find what is the right formula for people like me in academia that I can actually work on problems that are relevant and problems that are deserving some core foundational work. So today, I have this map created for myself that every research problem can start with a real problem. And that real problem can be learned through interfaces with startup companies, interfaces with technology companies. And being part of it is even a bigger plus because you can actually feel the pain of the customer every single day. And someone with my background, I can easily translate that into research problems that really, really matter from a fundamental perspective. And I'll work on that. And what I mean by that is I work on translating the idea into a prototype, transforming a prototype into a solution that can be broadly demonstrated. And then that solution can be picked up with a company like Reconstruct. And we can, make sure that transform into a proper product that's being validated with proper ROI established for it. So we can close the cycle of product idea to product. That cycle typically doesn't exist in academic work. In academic work, we dominantly work on ideas to prototypes. In the startup world, we typically work on low-hanging fruit opportunities for commercialization, and we transform into solutions. But if you really want to fundamentally solve the problem of the industry, as an individual, you have to be part of the entire chain of going from that idea to the product. So this faculty entrepreneurial fellowship was really an opportunity for me. When I came back to University of Illinois, I spent a few years outside a different university. When I came back, I was actually at Virginia Tech. When I came back, through my interaction with the team that was interviewing me, I specifically had interest in understanding what is sort of the roadmap for College of Engineering for entrepreneurship, because I had this interest of being in both sides of the work, solving real problems, but solving those problems through real solutions that are coming from science-based research. And there was a lot of positive feedback at that point in time. And College of Engineering decided to launch this new program called Faculty Entrepreneurial Fellowship, which is basically a cohort of faculty members that are being recruited, and their teaching is bought out by the university with the goal of them focusing on translating that prototype into the basis of a startup company. So now at that point in time, I was going through my tenure process, and I was an assistant professor. And for a university like University of Illinois, where we are, tier one in dominantly top, departments, top 5 across every engineering department. It's really a risk of getting engaged in something that does not translate into value from an academic perspective. But, with my passion, I decided to join that cohort. I was actually the only professor in that cohort that was non-tenured at the time. Everybody was already past at the stage. But again, with my passion, I love to solve real problems through real solutions. So I signed up for it, and with the university support, we were able to transform a project in its early days. It was actually called Flying Superintendents into Reconstruct.
Wow, that's amazing. So we're going to take a little break and hear from our sponsors, and then I want to hear a little bit more about that kind of ecosystem piece and how it informs what you do on a day-to-day basis. But we're going to hear from our sponsors, and we'll be back shortly. And we are back with Mani Golparvar. And, I want to continue talking a little bit about, some of the students in this entrepreneurship program, because you mentioned something about kind of ecosystem, and that, even working with some of the entrepreneurs and students informs your own work. But are you seeing some cross-pollination, even with, startup founders in completely, disparate verticals, but, are there lessons learned and some kind of streamlined lessons that you can, pull out of working together in that environment?
Yes. So, this journey of working through academia and then, getting engaged in a startup led me to think that, this model can potentially scale and can scale across all kinds of problems that people are working in academia. At the same time, it can offer an opportunity for people out in the startup world, in the technology world, to interface better with the academics. So as part of that, about 2.5 years ago, a group of us, I started meeting with a few faculty members here at the University of Illinois, and actually some of our partners at Carnegie Mellon. And we thought, all right, this model does deserve an opportunity for a scale up. And the opportunity was specifically bringing the industry together with startups and academia and formulate an institute that can streamline the transformation of ideas into products. So we went out to the industry and we started seeking support to see if they're on board with even this idea of meeting with a number of faculty members of startups on a regular basis and kind of helping this ecosystem grow in every aspect of it, and the fundamental work in terms of the startups working on more relevant problems, streamlining the transition of ideas into solutions for the market. So we noticed that there's an opportunity at National Science Foundation for planning for institutes of AI. Of course, there's been a lot of energy and resources being provided on growing AI broadly in the United States. So we wanted to tap into that opportunity. And industry was extremely excited about this, and they all started providing us with support. So in almost 10 days, we were able to secure 10 letters of support from various construction companies, top 10 ENR companies, construction, design, owners, in every sector, from oil and gas to data centers to commercial sectors. And we put a proposal to National Science Foundation and another agency here in Illinois called Discovery Partners Institute. So we secured funding to plan for the first institute of AI in construction in the United States. And so far, we've actually conducted 2 workshops, and our team has grown to a little bit over 185 individuals from all companies that are eager to be part of this. And what it really means is, one, for academics to understand what are the problems that are really relevant from a practical perspective, which deserve foundational work. For startups to figure out what are the opportunities for them to shine and bring solutions to the market. And for the industry to make sure they're getting engaged in this entire ecosystem and they can put their resources where it really matters to their own initiatives and their own roadmaps. With the ecosystem growing, it's important to make sure that industry resources also spent properly. So that scale up has really been over the past year and a half, and we're hoping that we can transform into a longer term institute that can serve the entire industry in the long run.
So it sounds like there are a lot of parallels with, your own experience, just having built at least 2 companies that you've shared with us today. But what are some of the differences in terms of, how you measure success for each of these programs? Because, there's one kind of set for, building a startup, but then academia adds another layer of complexity, and then you're adding enterprise into the fold. So how are you measuring the success of that?
Yeah, it's an interesting question. So, success in academia is measured by, scientific impact, and it's usually measured by the number of citations that you get in your articles. And, if you want to really translate into something that's more tangible for the industry, that means, how many times we end up presenting these concepts at conferences, perhaps keynote speeches across industry events, things of that nature. These are not things that university would really track, that citation and the amount of funding you allocate and how many students go through cohort of that idea. These are the metrics that we usually measure. But on the industry, it's completely different. Now, for a moment, I want to wear a hat of someone like myself. For long, I've been presenting the underlying idea of Reconstruct prior to having a company. I was working on it for a few years, and every time I was presenting, there was a lot of great feedback from the industry that we really, really wanted. What I was trying to do at the time was really trying to paint a picture of the future for the construction industry. It wasn't something that anyone was looking at and say, gosh, you know what, I'm going to be immediately using it. And perhaps at the time, I was not completely seeing the way industry is giving us feedback. I was thinking that, yes, immediately this is going to translate into something that everybody can use. So we started thinking about metrics that really matter for the industry. And at the time, we formulated a number of KPIs that measure success of a progress monitoring system to a construction project. But then when we started working more from a commercial perspective, these KPIs started looking very, very different. When companies want to pay money to start using that idea, now the way they measure impact is totally different. It's no longer a future that you're painting for them. It's their today's practice. What does it do for me? What does it do for my team? So that meant for us immediately start thinking about establishing KPIs at a project level, establishing KPIs at the persona level. By persona, I mean, what is the value of this to a superintendent on a commercial project? What is the value of this to a project manager? What is the value to the owner? What is the value to the director of quality? Does it matter to measure it differently in the industrial sector versus the commercial sector? And now, wearing my academic hat, this is totally different from the type of metrics that we use. I mentioned about citations, but if I want to take it one layer down, from an AI perspective, I would start measuring precision and recall of my algorithms. How good is my algorithm? But at the industry level, that matters, but what it matters is how much money you're going to be saving with this algorithm, how much time you're going to be saving. So being able to bring 2 layers of KPI in every work, understanding that we have to solve scientific problem, demonstrating that we made some improvement in precision recall, and other scientific metrics that we use. At the same time, at the industry level, we are working on KPIs that matter, is actually bringing a completely new perspective, not only to my work, to many other colleagues that are part of journeys like mine. Of course, the other co-founder of the company.
Yeah, and that makes sense too. And it's kind of like the challenge of any startup. It's like, you have to deliver value immediately, but I like the idea that you're thinking of this in kind of an industry industry terms, because there are, I think, companies now really embracing technology, but in AEC, it's, there's still a lot of archaic systems. You mentioned paper and pencil, and I had to think, God, if I had to put my hands on a pencil today, like I would have to like turn the house upside down. And so, how, is that chasm growing wider of companies who are adopting technologies versus ones who aren't? And then what do you think the resolve is? Like, how do we start getting companies who are, maybe falling behind on a technology level? How do we get them up to speed so that they can still compete? Because it's not like they have a lot of time now. Like, technology is moving very quickly.
Yeah, excellent point. So on the KPIs, let me just add one thing on that. What I've also realized over the past, I'd say 5-6 years, is we need to have RI and KPIs that measure tangible impacts versus things that are less tangible. And I really mean it, because what I've realized is construction companies, they have low margin of profit. So when it comes to expenditure for technology, it really goes into general condition line item in terms of the money that is spending broadly to support a project. So that's competing with many other things that are a necessity to a project. So when you have limited budget, you really want to know what is that most tangible benefit that you get by adopting and adapting a solution to your practices. So over the past few years, we've actually established these practices, and I can kind of see it. Other companies that are in the construction technology world, they do that too. When it comes to marketing, when it comes to broad presentations, the less tangible metrics are being shown, but when you actually get engaged in the sales process, you see how the more tangible KPIs are being used. But I think your question is, so given the fact that there's limited amount of resources to be spent, how do you prioritize what is it that you should be using? So first, at the industry level, I think it's really important to educate owners. Owners are the ones who really leverage value from any type of technology we use. Of course, the technology is going to be used by a contractor, but the contractor is going to use it for the purpose of delivering a physical asset back to the owner. So if we can actually help the contractor do their work better, faster, with less amount of rework, that means a better project delivered to the owner. So it's really, really important for the owners to be educated on the value that technology can bring in. And there are many different ways of doing it. For a company like us, we actually directly try to establish business relationship with owners. For contractors, that means actually trying to educate the owner of their projects on the value of technology by bringing us as a partner to meetings, or even including us in their bid proposals to owners to demonstrate the value of the technology. So now, what kind of companies are actually tapping into that as an opportunity? Technology can always be a differentiator. So if you're actually smart from a construction perspective, you can use that as a plus in your bidding practice to bring in something that give you a competitive edge. So if you're the contractor, you can work with a company like us. You can formulate a bid package that demonstrates additional value add through a technology. So one, educating owners and making sure the owners would actually make technology a requirement works. The other one is to make sure that contractors work with technology providers to demonstrate the value of technology. This strategy has actually worked. So it's not just experience of an early stage company like Reconstruct. It has worked with BIM-driven projects. So BIM, building information models, these 3D models that we use as a base of design. So if you think about it, in the early days, from a design coordination, those designers and construction companies that create shop drawings, they all understand the value. But the reason that it started scaling up is that owners actually made BIM a requirement. And when you actually engage the owner in understanding that value, and they make it a requirement as part of a project execution, the value and scales up dramatically. And I think we can tap into that experience and use that with the same strategy for other early stage companies like Reconstruct.
Yeah, we're definitely aligned on BIM, but still there are companies that just, I just can't seem to bring it into their workflow, and that for sure is going to become a standard, just in the same way I think digital twin will become a standard. So are there some technologies that are, that you've seen, whether they are kind of symbiotic with Reconstruct or just interesting technology in, in our industry in general? What are some of the things that you've seen maybe around automation or maybe around, of course, immersive technology? I'd be very, very happy to hear about. Are you seeing any other technology that you're really wowed by?
I happen to work in, some of the fundamental aspect of creating these technologies, right? So I'm mostly going to make my comment from that perspective. So first, one thing you mentioned, I want to get a little bit deeper into, which is, past, I'd say 2 years, the change in the way we work has actually brought more attention to technology in the construction sector. We've all realized that when you're removed from your job site, you need to have your eyes on the project, and without being on job, you can actually get work done. All you need is that layer of transparency of what is happening. So broadly speaking, technologies that are like us, reality mapping, I call our technology reality mapping. We call it reality mapping because we map the site in 3D and 2D. But broadly speaking, the term that's used is reality capture, which is pinning images and video frames against floor plan. This technology has dramatically grown. It's a necessity. Many project team members are actually using that as a base of design coordination, construction monitoring, even facility management purposes. So broadly, because of that attention, there's a number of fundamental works that are contributing to it. So when I started working on this, more from an academic perspective, I really wanted to make this practice to be completely autonomous end to end. The process of the data capture, the process of analyzing the data, and generating actionable insight and reports back to companies that we work with. Now, fast forward to today's date, there are a few companies that try to bring end-to-end services, not technology solutions. So I'm excluding that for a conversation. But if you think about that autonomous capture, that end-to-end pipeline, that means making the data capture to be autonomous. We took project teams from that paper to this idea that if you have one person with a 360 camera mounted on their hard hat and they walk around and videotape, we can get measurable studio experience for everybody else. But now that this is scaling up, people are asking for more autonomy on that front. Why should that person walk on the site in the first place? Can you leverage a robotic platform that can autonomously do that data capture for you? And of course, there are certain robotic platforms that have matured enough. Drone is a really good example of that, right? If the FAA regulation was not a barrier, I would have already seen autonomous operation of drones. It does require fundamental work, so not the entire scientific problem is solved. For example, understanding where change is expected to happen, being able to autonomously guide your robot into that location without manual input. That's an exciting area that I think in the next, I'd say 2 to 5 years in short term, you're going to see that becoming part of project teams, not only drones, but also ground robots of all form factors. I don't work in robotic control area, but I do work on software for robots. So I've actually created prototypes for indoor, ground rovers. They can carry cameras, they can carry other sensing devices to do the capture. So that's a pretty active area, both from a startup community perspective and from an academic perspective. There are bits and pieces that everybody's contributing to. And of course, then you get platforms like Boston Dynamic that the robot itself is very mature. It's getting really good traction. I think you're going to see more of that. So if you can position that properly into that end-to-end workflow, any robotic platform then you can justify the cost for paying those platforms. So in the short term, that robotic piece is going to be something that I'm excited about. I'm thinking that this is going to be part of everyone's practice. It's happening faster than I thought. I thought there would be a cultural resistance to this idea that robot would be coexisting with the workers and management team. But if you can save from that administrative work, I don't see any harm in any form or shape. So that's one end of the spectrum. On the other end of it is purely on the data analytics. So over the past a few years, many AI algorithms, many AI solutions have matured. And that's why many leading technology companies are providing AI platforms to startup companies to do the development. So the trend has been dominantly toward predictive data analytics, meaning using the trend of data to predict something that may happen to a project. As an example, at Reconstruct, we predict the likelihood of delays in a project schedule, and we can bring that visibility. But I think the area that I'm personally really excited about is prescribing what needs to be done as a function of that prediction. What I mean by that, I want to share a really tangible example. Imagine with Reconstruct platform today, if you go into a coordination meeting, you will have this really large monitor in your trailer, and you can put Reconstruct up there, and you can immediately see what are the locations, work areas that are at risk of delay. One red, one yellow. And everybody's rallying around, all right, so how do we revise the schedule that we can minimize the impact of this potential delay on the project? But imagine us offering you 3 alternatives. These are your top 3 recommended alternatives on how you can revise your schedule, so you can actually make sure your project comes back on schedule and on budget. That's a totally different way of thinking about this problem. And because of the maturity of AI algorithms, because of availability of data, I'm excited about working on these solutions. On the university side, transitioning to things that can be used at Reconstruct, for me, it means I've been working a lot on natural language processing, which is a variation of AI, analyzing text, to see if we can use that to understand project schedules and prescribe how a schedule needs to be revised based on relationships, logic that's built into, and of course, based on progress that gets documented and predicted to Reconstruct. So on 2 fronts.
Oh, sorry. Yeah, sorry, go ahead.
Robotic and prescriptive data analytics, if I can use that buzzword.
Yeah, no, and I thank you for kind of also sort of distilling that down. I think that's great. And you do spend a lot of time thinking about the future. So I think it's only fitting that our wrap up question. I bet not only do you have some good ideas about it, but I bet you could probably build half of them yourself. But if you could project yourself 20, 25 years into the future, and you could just bring with you, any product or service that would make you happy or just make your life better in some way, what would it be and what would it do?
Yeah, that's a really good question. Like many other people that are perhaps listening to podcasts, we all think about, what are our short-term goals and what are our long-term goals. So when I started, getting to this journey, the journey of interfacing academia with the startup world and technology world, I set myself 2 goals. One was, in the short term, I want to bring the academic work out to the industry, which to some degree we've been doing that for the past few years. But the other goal that I set for myself was not actually 25 years. It was actually slightly shorter time frame. From the time of the idea, 10 years that the solution becomes a dominant solution that gets practice. Now, predicting future in 25 years is actually really difficult because the cycle of idea to product is getting shorter and shorter. If you go back to the time that people were working on, for example, mobile solutions and bringing a smartphone out, the time was 10, 15 years. But now with many aspect of technology that's mature, bringing ideas is being accelerated. And of course, there's a lot of funding that's being allocated. So 25 is a little bit difficult for me, but what I would love to see happen is a lot of painstaking administrative work that we do in construction to be completely autonomous. So we can have our people focus on more value-adding tasks. And I don't see that that level of automation making any concern. Every project team is understaffed. I'm sure many people that are listening to me, they understand it. We always start a day really early in the morning and we wrap up the day really late. Some of us, we show up on the job site Saturday morning. It doesn't have to be that way. There are solutions that can be brought out, and I think those will be brought out to make sure that everyone is having a good experience in the construction world, and we can focus on value-adding activities.
I love that. And here's the good news. I think you're going to get your wish. Well, Mani, it has been an absolute pleasure speaking with you today. Thank you so much for joining us.
Thank you. Thanks for the opportunity.